We went through the explanation of unicast IP addressing, but there are a couple of points that we need to mention to get a full picture of IP version 6 operations. The first is IP version 6 neighbor discovery. This improves upon IP version 4's implementation of ARP and ICMP and is the process of tracking the reachability of neighbors on the link. If the neighbor receives and processes IP traffic or neighbor solicitation requests, then the device is seen as being reachable. Duplicate address detection determines whether an address is already in use by another IP version 6 enabled node. All other interfaces must implement DAD regardless of whether the address is configured manually or by using DHCP version 6 or SLAAC, but this can be disabled for a specific interface with the DAD disable statement. So this is our topology. We have two devices which are directly connected, but to provide reachability to the IP version 6 loopback addresses, we need to configure static routing. Now we can still configure additional options like the static route preference and qualified next hop, but the main thing to remember is that IP version 6 static routes must be configured in the INET 6 RIB, which is the IP version 6 routing table, rather than the default INET 0 RIB, which is for IP version 4. With OSPF version 3, you enable OSPF version 3 almost the same way you enable OSPF version 2. Also, OSPF version 3 still uses a 32-bit router ID. The only difference is that when you use the OSPF 3 statement in place of OSPF at the edit protocol's hierarchy level. This is also the case when running show and verification commands. Note that the neighbor address is displayed as the IP version 6 link local address. IS-IS. IP version 6 is enabled by default with IS to IS, so there's no need to invent a brand new protocol as they did with OSPF. The only explicit configuration needed in IS-IS with regard to IP version 6 is if you want to disable it as follows. Otherwise, the rest of the configuration is pretty straightforward. The same is also true for BGP. We set the autonomous system number under the routing options, set the type and the peer address of our neighbor. The major difference is that the neighbor address is now set as the directly connected interface if it's an eBGP peer, or if we are doing an IBGP peering, we want to make sure that we have reachability to the loopback address for local address peering, and we set the BGP type to internal. Finally, we come on to tunneling IP version 6 traffic. IP version 6 tunnels are used across IP version 4 networks until all the routers in the path are upgraded to be able to use IP version 6. The IP version 6 packet is encapsulated within IP version 4, which is then forwarded across the IP version 4 network to the other side, where the IP version 4 header is removed and the IP version 6 packet is processed. There are a number of ways to do this. You could use 6PE, 6/4 tunneling, 6-4 tunneling, configured tunnels, IP version 4 compatible addressing, and so on. And this is a configuration for setting an IP version 6 over IP version 4 tunnel. So with IP version 6 routing operations, what I'll probably do, I probably won't cover tunneling, but I'll make sure I cover all of the routing protocols, including static routes. And the topology that we're going to be working with is going to be a very basic topology. We've just got VMX R1 and VMX R2, and they have two loopback addresses connected. And these loopback addresses are what we're going to try and advertise in the routing protocols to get reachability. And I have R1 and R2 terminal sessions already open. All I've done is the actual IP addressing, so we can see that they've got IP version 6 addresses. If I do just show interfaces, and I've configured a loopback address of FD00::1, and the directly connected addresses is 2001 ABCD::1. So I should be able to ping the directly connected ABCD address, but I shouldn't be able to ping R2's loopback address. Let's just test that out now. And I am able to ping the directly connected address, and let's try the loopback. Did I say it was FD00? FD00::2. And you can see there it says no route to host, so we don't have reachability. And the first one that I will configure is the static routing. Now, static routing is still configured for IP version 6 under the routing options. If I say edit routing options, but the caveat or the difference in this is that you have to configure the RIB, the routing information base of INET 6. And obviously we know that INET 6 is the IP version 6 routing table. If I say RIB INET 6. Now, the important thing here is, even though under the interfaces we say it's INET 6, here you have to say INET 6.0. If you don't say INET 6.0, your static route will not work. So we say edit routing options RIB INET 6.0. If we say static, enter, and then we're going to say set the route as we're looking to get to FD00::2, and our next hop will be 2001 ABCD::2. Let's commit that, and then let's do the same on R2 to have reachability back. Give us a bit of practice as well. Edit routing options. Again, I can't stress this enough. You can learn from my mistakes. I spent like 15 minutes wondering why this wasn't working before. When you say the RIB, you have to specify INET 6.0 static. And the reason for this is when we do the show, look in the route table, run show route table, and if we do a question mark here, we can see that the table, which is your routing information base, is either INET.0, which is the default, or INET 6.0. Again, if you were just to put INET 6, it would not work. So we know that already. So what we will say now is set route to get to the FD00::1 network. Our next hop will be 2001 ABCD::1. And that should be it for the static route. Now if I jump on, well, I can do it from here. So from here now, I should be able to ping R1's loopback address, FD00::1, which I can. So the static routing works fine. Excellent. What I will do each time, I will just say rollback 1, and that should get rid of the static routing. So if I say now show routing options, there's no configuration there, and I'll do the same on R1. Rollback 1 and commit. Okay. So the next routing protocol that we'll look at for IP version 6 is OSPF. Now, OSPF version 3 configuration is almost identical to OSPF version 2, except when we do the configuration, we say edit protocols. Instead of saying OSPF, we say OSPF 3, and we say area 0. But I want to show you something before we do this, because even though this is IP version 6, the router ID is still an IP version 4 format, so it's a 32-bit IP address. So if I say edit routing options, I'm just doing a show there to show that there's nothing, and we can set the router ID. Set router ID on VMX R1. I will make it 1.1.1.1. Actually, I can make it anything. Let's just to prove that it takes the router ID from here. Let's say on this side 1.1.1.123, and then we can continue with our OSPF configuration. Top edit protocols OSPF 3. We're going to put them in area 0, and the interfaces that we're going to advertise, set interface GE000. Oh, there must be something else that has inter, so inter F. GE000.0 and also set interf loopback 0.0. We'll make that passive. Let's commit that. We now need to know that we have to do a rollback 2 to go back after this commit. And we'll do the same on R2. Edit routing options. We're going to set the router ID as 2.2.2.123. Top edit protocols OSPF 3 area 0, and we're going to set the interf as GE000.0, and we're going to advertise the loopback as well. Set interf loopback 0.0 passive. What I should also do is, I'm not going to do it, but what I could also do is set the link local address, because we know that with the routing protocols, they use the IPv6 link local address for communications. So we will see that when we look at the OSPF show commands. Let's commit that. And now let's say run show OSPF. The only difference is we need to put a 3 on the end of the OSPF command. So run show OSPF 3 neighbor. And we can see that our neighbor's ID is the 1.1.1.123 32-bit IP router ID. And we can see that our neighbor address is our link local address. And we can also do run show OSPF 3 overview. It looks to me exactly the same as a normal OSPF version 2 overview. It's just that OSPF 3 command. Let's have a look at run show OSPF 3 interface. Yeah, and all the rest of the configuration commands look the same. So that's it for OSPF 3. Let's do a rollback 2 and do a show interface just to make sure nothing else. Yeah, and we'll do the same on VMX R1. Say rollback 2, and let's commit that. Let's commit it on this side. All right, now when we're moving into IS to IS, we already know that in IS to IS, it had compatibility for IPv6 by default. So theoretically, all I should have to do is say edit protocols, IS, and advertise the interfaces. Set interface GE00.0 and set interface loopback 0.0. Let's commit that and say run show IS adjacency. Nothing. Let's do the same on the other side. Edit protocols IS. IC. No. Set interface GE00.0 and set interface loopback 0.0. Let's commit that. Run show IS adjacency. I'm losing all of my basic IS configuration skills. We need to make the interface under the ISO hierarchy, and we also need to add the NSAP address. Let's do that quickly. So the first thing I will do is edit interface GE00.0 family ISO. And then also what I need to do is set interface loopback 0.0 family ISO address, as we're on R1, so make it 49.001.123 .00. Let's commit that. That's 4 commits back now, I think it is. And let's do the same on this side. Top edit interface GE000.0 family ISO and top set interface loopback 0.0 family ISO address as 49 dot, that's our area, dot 1, no, 1, 2, 3 with a 2.00, 4 commits. Let's commit that. Run show ISIS adjacency. Boom, there we go. And we can see that we have both a layer 1 or a level 1 and a level 2 adjacency we're running. And we should also be able to ping the loopback. So run ping FD000, one too many zeros, colon 1. And we do have reachability. All right, let's see if this rollback 4 works. Roll back 4. Show. Yeah, it looked like it worked. Let's commit that and do the same on R1. Roll back 4. And the last one we're going to look at, let's commit that first. The last one that we're going to look at is BGP. And with BGP, it's a similar case. We say edit protocols. First, before we do that, let's set our autonomous system. I will have R1 as 4 and R2 as 1, 2, 3. So edit routing options. Set autonomous system as 4. Top edit protocols BGP group. Let's call the group just RC, router coach external. Set our type as external. Set our peer AS as 1, 2, 3. And also, what else do I need to do? I also need to set the type as external, set the peer AS as 1, 2, 3, set our neighbor, and our neighbor address is going to be the directly connected address, which is 2001 ABCD, colon, colon, 2. I think that's it. Let's commit that. And do the same on R2. Edit routing options. Set our autonomous system as 1, 2, 3. Top edit protocols BGP group is going to be called RC external. Set our type as external. Set our peer AS as 4 and set our neighbor as 2001 ABCD colon, colon, 1. Let's commit that. Run show BGP summary. And we can see that well, it's still saying active at the moment. Let's expand that. Let's give it a second or two. And it is now established. But I probably won't be able to ping the loopback addresses because I haven't advertised them into BGP. Run ping FD00 colon, colon, 2. Oh, I have reachability. Okay, excellent. I don't know why that is, but superb. Let's have a look in our routing table and see why that is. Run show route. And we have, which one was I actually pinging? Was I pinging the correct one? Let's see. I was pinging our own address, that's why. And we have a reachability to the other side. Okay, I just need to do a bit of a check to see why that is. Run, show route. Maybe I didn't take off some of the other commands. So we're looking for FD001, and it said it has reachability through the static route. So our static route is still there. And just to let's check that. And if I say show routing options, yeah. So when we went rollback 4, it wasn't far enough back, and we still have access to the neighbor's loopback address through the static route. And if I didn't have that, what I would do a policy, and I would advertise our directly connected and local routes into BGP to have reachability. But as we've got it through the static route, I'm not going to do that. That is it for IP version 6 routing operations. I'll see you in the next one.